Good morning. In this video, we begin a study of the content of Chapter 26, which includes light refraction. Before beginning, I'll point out to you that an important speed to be aware of is the speed of light in a vacuum or air. It's symbolized as c, and it's 300 million meters per second, equivalently 186,000 miles per second, written as 3 times 10 to the 8th. In glass or water or any other transparent medium, the speed of light in that medium is less than the speed of light. And to determine what that speed is, we can use the following equation, which really is the defining equation for a property of materials called the index of refraction. It's defined to be that ratio, the speed of light, which is the largest speed light can have in a vacuum, c, divided by the speed of light in the particular medium. 3 of the more common indices of refraction that we deal with in this chapter are the indices of refraction for air, water, and glass. Those indices are shown here. Notice that the indices are dimensionless. That's because the index of refraction n is defined to be the ratio of 2 speeds. The units cancel. I show here an interface between 2 different media, both transparent. It could be air, water, air, glass, glass, water, water, glass. Pick any 2 transparent media, we don't care. I show a ray of light originating on the left side of this interface. Perhaps it's originating in air. That ray of light is incident on the interface between the 2 media, left versus right, and that ray is called the incident ray, and it makes an angle of incidence, theta 1, the 1 subscripts meaning that it's originating from the first of the 2 media, left versus right. The angle of theta 1 is measured with respect to a normal line that is perpendicular to the interface. Normal means perpendicular. The ray then passes into the second medium, and in this case it happens to bend to its right, making an angle of refraction equal to theta 2. Our goal in many problems involving refracted rays is to determine the angle of refraction, theta 2, if you're given theta 1, and you're also told the 2 indices of refraction. So we have Snell's law that will be put to use for that, to that aim. Index of refraction times the sign is a constant across the interface. N1 sine theta 1 equals the same thing, just change the subscripts. I show an example of an interface between air and glass. The angle of incidence is 50 degrees. We wish to calculate the angle of refraction. Substituting for N1 and N2, we have this equation, 50 degrees for the angle of incidence. Rewrite this equation like this, and then recognize that theta 2 is the arc sine, or you can say the inverse sine of that ratio. So theta 2 is the angle whose sine is that ratio, and your calculator will show that the angle of refraction is 30.7 degrees. That concludes this first part, first of several videos for Chapter 26. Have a great day. Oh, stay safe. Don't touch your face.